Very good morning to one and all present here. Firstly, my name is Shahil Tanna. Currently, I'm studying in Rai University, coding Gita student, and right now I'm in third semester. And today, this video is gonna be all about the linked list, and we are going to solve a LeetCode problem based on this very linked list. So, firstly, directly right before jumping onto the LeetCode problem, we'll just have a look at the linked list, its overview, and how it is used and its memory allocation. So, firstly, what is linked list? Here you can see the example of a linked list, the singular linked list. So, let me just tell linked list is a type of data structure that is linear. It means that the memory allocation in this linked list is non-contiguous. It means that there can be any data after a particular data, and a linked list is dynamic, so it's better to use linked list when we have some problems related to insertion, updation, or like that, or deletion also, because when you use an array, it's not dynamic, it's static, and you can't do anything. So basically, linked list, it contains of a node instead of an element, and a node, it consists of basically two parts. The first one is the data, and the second one we can see is next. So basically, the data, it refers to the value, the normal value that we use whenever we have to search an element or we have to do some stuff with it. And the next will point to the very next element. It means that this is first element and this is the second element. So like the first element, it will be the data, and next it will store the address, or it will point to the second node. So it's very easy, and there are totally three types of linked list: singly, doubly, and circular linked list. But today we are just going to talk about the singly linked list. And singly linked list is this one that I explained to you, and the only thing that I need to add is that when a singly linked list is about to end, so the last node is there, then the next of the last node will be null. It indicates that our list has finally ended, and yeah, so we'll just finally go to LeetCode, and we will solve a problem related to reversing a linked list. So I guess it's 206 problem. Yeah, it's very easy. We'll just try solving it. So firstly, whenever you're solving a LeetCode problem, you should have a look at the examples that they have given, and you should read the description twice or thrice for better understanding for what kind of approach you should do, and the time complexity and space complexity that you should keep on mind while doing the algorithm. So basically, we'll read the description. Given the head of a single linked list, reverse the list and return the reversed list. So basically, what it's telling you is that they are going to give you a linked list. It will be having n number of elements, and then we have to just reverse, and we have to give the new reversed list in the output. So you can see that the first element will be the last, and last will be the first after reversing. And we can see there are three examples, and the last one here we can see that head is empty. It means that the linked list is null, and we have to ensure that if whenever the user enters an empty linked list, it should return empty. So basically, from here we will just start. It's very easy. If the head equals to null, and what we'll do is just that we will just return the head. It is for the worst case scenario when there is no element. Okay, so we are done with the if part, and in the else part we are going to use a three-pointer approach. Let me just write the three-pointer approach for you. So we are going to use three-pointer approach. The first one is current. So the current, as we all can guess from its name, it will keep the track of the current element that is getting looked after. The next, we have initialized it to null. It means that it will look after the very next element that is about to get accessed, and the previous, it will keep track of the previous elements that we have accessed. So far so easy. Now it's obvious that we're going to use a while loop, and we are going to write current is not equal to null, because we all know that whenever we are reversing, we are going to reverse the whole linked list, right? So we are going to check each and every element, and we are going to have n number of iterations according to the element. And while current is not equal to null, it means until the last element, we are going to perform this operation in this particular scope. So firstly, what we will do is that we'll give next equal to current of next. So basically what we are going to do is that, supposingly in this one example, the current is gonna be 1, like the head. So we are going to give next as 2. It means current of next is gonna be next. Okay, and then we are going to give current of next to previous. It means that current of next equal to previous. It means that in first iteration, the current of the next of the current, it is going to be null. So it will be stored in previous for this very iteration. And then what we are going to do is that we are just going to update the values by giving these arguments, so that after each and every iteration, our last element gets inserted, our current and our next element, it gets updated. And then at the end, what we are going to do is that we are going to return a previous. So let's just try running this. Okay, so we can see that we have gone through all the test cases, and even the third case where it is null, we have passed it. And it was very easy. Let's just check if it passes all the test cases. Okay, so we can see that all the test cases have been passed. So let's just, for a better example, we will have a look at one of the dry run code. So in this will be the first iteration. So in first iteration, as we all know, the current will obviously be 1, our first element. So we are just going to give next as the next of current. It means that in next, it will store the value of 2. And then current of and then next of current is going to be previous. So the next of 1 is going to be null because it's first iteration. So there will be only one element, and then we're going to give values previous equal to current and current equal to next. So that will just update the values. And after first iteration, we can see our list will look like this: previous, 1 and null, and current will be 2, 3, 4. So like that, after our iterations are done, then our list will be like 5, 4, 3, 2, 1 and null. So yeah, it just depends on what size is the linked list, and it will keep on executing the loop unless and until the condition is false. So I hope that you had a better understanding from my video, and I'll have a look at you at the very next video. See ya.